You know how we've been searching for alien life on exoplanets for decades? Well, scientists are now realizing we might have been looking in completely the wrong place. Forget rocky planets in the habitable zone for a second. What if I told you the most promising place to find life beyond Earth might not be on planets at all, but on their moons? This isn't science fiction anymore. We're talking about exomoons, moons orbiting planets outside our solar system. And the hunt for them is one of the most exciting frontiers in astronomy right now. The idea is mind-blowing when you think about it. In our own solar system, we've found worlds like Europa and Enceladus that have subsurface oceans and potentially habitable conditions, despite being frozen ice balls on the surface. Now imagine that scaled up across the galaxy. The first confirmed exomoon candidate, called Kepler 1625b, was detected orbiting a gas giant about 8,000 light-years away. It's potentially the size of Neptune, which is absolutely massive for a moon. But here's where it gets really interesting. Finding these things is incredibly difficult. Planets are hard enough to spot. They're just tiny blips of dimmed light when they pass in front of their stars. Moons are even smaller, and their signals are fainter. Scientists use multiple methods, including transit timing variations, where the planet's orbit gets slightly delayed because of the moon's gravitational pull, or transit duration variations, where the planet's shadow lasts longer because the moon is contributing to the blockage. The James Webb Space Telescope is about to revolutionize this search with its incredible sensitivity. It could potentially detect atmospheres around exomoons, which would be a game changer. Imagine finding an exomoon with water vapor, oxygen, or even signs of biological activity in its atmosphere. That discovery would fundamentally change our understanding of where life can exist. But why are exomoons so promising for life? Think about Jupiter's moon Europa. It's locked in an orbital dance with Jupiter that creates tidal heating, keeping its subsurface ocean liquid despite being far from the sun. An exomoon orbiting a gas giant in the habitable zone could have stable temperatures, protection from stellar radiation by the planet's magnetic field, and potentially even geological activity driven by tidal forces. The diversity of possible exomoons is staggering. They could range from small, rocky bodies to ocean worlds to even moons orbiting other moons. The potential for finding exotic environments is enormous. Some theories even suggest that free-floating exomoons, ejected from their planetary systems, could maintain subsurface oceans for billions of years, making them dark, wandering habitats in interstellar space. The challenges in detecting them are immense, though. We're talking about needing multiple transits to confirm a signal, ruling out other explanations like star spots or binary star systems, and dealing with the fact that most detection methods work best for large moons orbiting large planets. But the payoff could be astronomical. Finding an exomoon with the right conditions for life would suggest that habitable worlds might be far more common than we thought. It would mean that life could thrive in places we never considered, orbiting gas giants instead of sun-like stars. The implications for the Fermi paradox, the question of why we haven't found other intelligent life, would be profound. Maybe advanced civilizations develop around gas giants with multiple habitable moons, creating entire miniature solar systems within planetary systems. The search for exomoons is still in its early stages, but with new telescopes coming online and better detection methods being developed, we're on the verge of potentially groundbreaking discoveries. Every time we think we understand where life could exist, the universe shows us we've only scratched the surface. Which moon in our solar system do you think is most likely to host life? Drop your thoughts in the comments.